All right, 1.4 quadratic equations. In section 1.1, we studied linear equations of the form ax plus b is equal to c, where a cannot be equal to 0. And we discussed a little bit about why a cannot be equal to 0, because if a was equal to 0, then it would just be b is equal to c. These equations are also known as first-order polynomial equations. In this section, we learn how to solve second-order polynomial equations. Second-order polynomial equations are called quadratic equations. So we read the quadratic equation. It reads, a quadratic equation in one variable is an equation that can be written in the form ax squared plus bx plus c is equal to 0, where a cannot be equal to 0. So similar to our linear equation where a cannot be equal to 0, because again, if a was equal to 0, then that would just be b is equal to 0, right? I'm sorry, b is equal to c. In this particular case, if a was equal to 0, then we would just have a linear equation, right? bx plus c is equal to 0. So that's why that is in there. Let's see what else. Oh yeah, when it read a second order polynomial, that basically just means that we're looking at the degree of the polynomial. Second order means second degree polynomial. I think this can fit. Excuse me. I think this can fit on the current page. Yeah. Okay. So some quadratic equations can be easily solved by factoring and by using the following important property. Mute your mic, please. The zero product property, or the zero product principle. If a times b is equal to 0, please mute your mic. If a times b is equal to 0, then a is equal to 0 or b is equal to 0. The zero product property says that if two factors multiplied together are equal to 0, then at least one of the factors must be equal to 0. We'll see in example 1 how this zero product property is used. Now, it is simply a times b is equal to 0. There's nothing wrong with that, okay? But it does also extend to the fact that, it's a times b times c times d is equal to 0. Then we can set a equals 0, b equals 0, c equals 0, d equals 0. And we'll see that, maybe not today, but we will see it in a later form. Okay, so example 1. Use factoring in the zero product property to solve a quadratic equation. All right, so we know that we know that when we want to factor a quadratic equation, we need to put everything on one side. So we're going to start this off with 6x squared minus 17x plus 12 is equal to 0. Okay, and let's see. We could we'll just go ahead and do the yeah, we'll go ahead and do the AC method. Okay, so the AC method, we get a times c, which is equal to, in this particular case, would be 6 times 12. Which is equal to 6 times 10 is 60, and then times 2, so that would be 72. Okay, all right, so we're going to look at the factors of 72. Well, 1 times 72, 2 times 36, times 36. 3 goes into 72 because it goes in 24 times. 4 does. 4 goes into it 16. You can see how this gets a little tedious, but that's another reason why I go in order, go on 1, 2, 3, 4, and so on. And these looks like they could be a little bit better. All right, 5 does not work. 6 will be 6 times 12, right? That's what we have actually. 7 does not. 8 does. It's 8 times 9, and then we rotate right back around to 9 times 8. Okay, so these are my factors of 72. And let's rewrite this, 6x squared, and we're just going to keep that blank for just right now. All right, so which one of these factors that when you add or subtract them together will give you this negative 17? Okay, well, it would obviously be this one, right? A negative 8 and a negative 9 gives me a negative 17. So we'll do minus 8x minus 9x and then plus 12 is equal to 0. And then we're going to split it down the middle. Okay, so what can I factor out of the left side? It looks like I can factor out a 2x. What remains? 3x minus 4. All right, what can I factor out of the left side, or the right side rather? All right, so I need to have a positive 3 and a negative 4 inside my parentheses here. So I'm going to factor out a negative 3. Because if I factor out negative 3, then what remains would be a positive 3x minus 4. Exactly what I'm looking for. All right, and then we can pull that factor form out. Would be 3x minus 4, 2x minus 3 is equal to 0. All right, now I have my zero product principle. So now what I can do is I can set up each one of these terms. So this is in the form a times b is equal to 0. Everybody see that? So I can say 3x minus 4 is equal to 0. Right? And then if I solve for that, it'd be x equals to positive 4/3. And then I can say 2x minus 3 is equal to 0, which will end up being x is equal to 3/2, positive 3/2. Right? So that's what we did. We just factor. We did AC method. So this is a nice problem that we could nice good return from a Labor Day weekend problem because it incorporates things that we did previously. All right, we'll just read that. Now we'll slip the whole thing. We'll do that. Let's do it. Okay, so this reads. Excuse me. I'm gonna take a drink here in a moment. Consider the quadratic equation x squared minus 9 is equal to 0. Left-hand side is a difference of two squares. So we can easily solve by factoring. So we know x squared plus 9 factors into x plus 3x minus 3. And then use our zero product principle, and realistically we can just look at it, right? We see that x equal to 3 and x equal to negative 3. Okay? So the solution is x equal to plus or minus 3. In fact, any quadratic equation of the form x squared minus c equals 0, where c is greater than 0, can be solved by factoring. And we see that here. We just factor it and get our solution. This leads us into the square root property, and I'll go ahead and snip that along with the example. Okay, so we've got three problems here. A, hang on one second, let me get a drink. All right, I'm back. Man, the first part of that was I had the mic on my mouth, so hopefully I didn't sound like a water buffalo there. Anyways, A, x squared minus 16. So we know that x squared minus 16, we know that's the difference of squares. Okay, so we can do this in one of two ways, and yeah, we'll just do it knowing that it's a difference of squares. We know that x squared minus 16 can factor into x plus 4 and x minus 4 is equal to 0. Therefore, we have x is equal to plus or minus 4. Okay, B, If we look at this, we can't really say, oh, well, hey, that's a difference of squares, because it's not, right? Because 72 is not a perfect square, neither is 2. But instead, we're going to have to hark back to what we've done previously. What we're going to do is we're going to isolate the variable on the left side. So we're just going to say 2x squared is equal to negative 72. All right, and then we're going to divide both sides by 2. So we're going to have x squared is equal to negative 36. We're going to take the square root of both sides. So we're going to have x is equal to plus or minus the square root of negative 36. And of course we know negative 36. If this were the beginning of a Algebra Essentials course, or Intro to College Algebra course, we would say, okay, well, this has no solution, right? But of course we know that does have a solution. It's just in the imaginary plane. Right, so this becomes, put it this way, a little indentation. So this becomes x is equal to, all right, so what I'm going to do is I'm going to pull an I out, remember? So it's going to be plus or minus I, and then it just becomes the square root of 36. Well, square root of 36 is just 6, right? So it would be I6, but we know that just looks a little silly, so we're going to say 6I. Okay. And lastly, we've got x minus 1 quantity squared is equal to 7. I am going to go ahead and square root both sides. So taking the square root of both sides, I'm going to have x minus 1 is equal to the square root of 7. Okay, and then we're going to add 1 to both sides. I'm sorry. We took the square root of both sides. It's going to be plus or minus the square root of 7, right? Okay, and then we're going to add 1 to both sides. So this becomes x is equal to 1 plus or minus the square root of 7. And C was the easiest one. All right, I want to snip this last sentence because this next, I think the next part we're going to be talking about is going to not be fun for you. And I just want to give you a proper introduction. Okay, so this reads, example 2, which we just did, we see that the quadratic equation x minus 1 quantity squared equals 7 can be solved using the square root property. The left side of the equation is a perfect square. In fact, every quadratic equation can be written in the form x minus h quantity squared equals k using a method known as completing the square. Okay, so let's see what's on. All right, so this reads the left side of the equation is a perfect square. What that means is at the very beginning, of the problem. So I'm still looking at C. It was x minus 1 quantity squared. All right, it was a perfect square. Okay, meaning that, well, there's, this can be rewritten as what? X minus 1 times x minus 1, but of course, we know shorthand to be x minus 1 quantity squared. Okay, so that's what we mean by it being a perfect square. And we're going to talk more about that hopefully next. Okay, I don't really know what else would be next. Okay. Okay, so let's consider the following perfect square trinomials. Let's see. How can we go about this? All right, so I'll just slowly or quickly talk about this because I do go about completing the square just a tad differently. I do think it's easier, but we'll see. All right, so let's look at x plus 1 quantity squared. Okay, x plus 1 quantity squared. If I were to FOIL it out, it would be x squared plus 2x plus 1. Okay, and what this down here is highlighting is notice that half of 2 and you square it gives me 1. Right, half of 2 is 1, 1 squared is 1. And it's showing that the relationship between this term and this term. It's showing the relationship between the b of the quadratic equation and the c of the quadratic equation. Okay. Same thing here. X minus 3 quantity squared, if I FOILed it out, would be x squared minus 6x plus 9. Okay. And again, it is showing half of 6, see, well, half of negative 6 rather. Right, half of negative 6 would be what? Negative 3. Negative 3 squared will give me 9. Okay, and well, we'll just go ahead and talk about the last one. What is half of 7? Okay, well, half of 7, or it would be negative 7. All right, well, I mean, it's nothing simple, right? It's just, but it is negative 7 halves. Now, this is also where it comes into play, where many of you might want to use a calculator for everything. Okay, you don't need to use a calculator for these types of problems. Now, I know that many of you will, probably really need one because you're used to it. It's a crutch. But, and this isn't the same thing, but, if we get to 49 divided by 3, you want to keep it in that form because it's a lot easier to manipulate algebraically than whatever 49 divided by 3 is in decimal form. Okay. So anyways, half of, did I say 7? Oh yeah, we're on the last one. Half of 7 is just, negative 7 halves. Again, if you put it in your calculator, you might say negative 3.5, and you're not wrong. But the problem is, when it comes to this, shoot, I forgot the word, algorithm that I use, it's really going to mess you up. So try not to use a calculator and keep everything in a fractional form. Okay, but anyways, negative 7 halves, if I were to square it, okay, negative 7 halves, if I were to square it, well, that would be the top squared over the bottom squared, which would be 49 fourths, which is this. And this is all this page is doing, showing the relationship between B and C, B being, again, the constant in front of the X, and C just being the constant by itself. It's showing the relationship between B and C in a perfect square trinomial. So let us look at some. I'm just going to put on the current page. Yeah, we'll do here. Okay, so A would say, okay, so what is half of negative 12? Well, that's negative 6. What is negative 6 quantity squared? That's 36. So we would add 36. B, we'll go and put a plus 36 there. What number must be added? I mean, it's just asking for the number, but I mean, if I were to write the whole thing out, it would be plus 36. But don't worry, I promise you we're going to get plenty of exercises on this. So 5, well, what is half of 5? Well, that's, again, 5 divided by 2. Well, that's just 5 divided by 2, 5 halves. Okay, don't put this in your calculator and say, oh, that's 2.5. Okay. All right, so 5 halves, and if we square 5 halves, well, what's 5 squared? That's 25. And this would also be a plus. 25 over, what's 2 squared? Well, that's 4. Yeah, 25 over 4. That's all we would add to this problem to complete the square. Okay. And of course, C has to come in with fractions. Nobody likes fractions, right? And this actually is a good time to talk about dividing by fractions. So this would be negative 3 halves divided by 2. Okay, now here's the thing. This does look, you look at it and you roll your eyes, right? But if you recall, this is just the same thing saying negative 3 halves divided by 2, right? Which we know when we divide fractions, we multiply by the reciprocal, right? So this is just what? Negative 3/4, right? So try to remember this, that it's this step whenever you look at this, right? And this is John Madden all over the place, but try to remember that, okay? And it's not just you. Many of my pre-cal students and previous calculus students still look at fraction over fraction and freak out. Okay. I mean, we said what's what we said it was negative 3/4, negative 3/4 quantity squared. Okay, and again, if we did this, negative 3/4 squared, well, we'd square the top, so it'd be 9, and then we would square the bottom, which would be 16. So we plus 9/16. Okay. And we're going to see why we're doing all this. I did tell you that, you know, we're looking for perfect square trinomials, but we'll really drive the point home. All right, I'm just going to snip this, but I'm not going to necessarily go by it. Okay, so I'm just going to keep that there for the notes. All right, and we're going to go ahead and jump straight into this. That's a new page. Okay, so for the sake of this particular problem, it reads solve by completing the square. Okay, and we have to solve it by completing the square because we can't just do the AC method. And how do we know we can do the AC method? Well, if we did 19 times 3, what's 38, 57? What are my factors of 57? That'll give me 18, and we'll see that we don't have an answer to that. Okay. Furthermore, at this particular stage in mathematics, I'm pretty sure you'll just be told to complete the square instead of solve, right? At the same time, we do know of a quadratic formula, which we'll talk about later, and that will just be the catch-all of how to solve these problems. But with that said, and actually I'll talk about it when we get there. All right, so completing the square. Here is my particular algorithm. Here's what I do, okay? I do have a kind of a steps thing here. And I'm pretty sure I pull a lot from it, okay? The first step, obviously, if a is not equal to 1, divide both sides of the equation by a, and then move all constants to the right-hand side. So that's definitely what I'm going to do. So 1 and 2, I do first off every single time. So let's go ahead and do that. So looking at this problem, we see that the a value, 3, is not equal to 1. So what I'm going to do is divide the entire problem by 3. So if I divide the entire problem by 3, I'll have x squared minus 6x plus, oh, well, this sucks, right? It's 19 divided by 3. So this is already looking like a bad time. Okay. Next up, what I'm going to do is move all the constants to the other side, and I'm going to fix that 19. I don't really like the way that looks either. 19 over 3 is equal to 0. And then we're going to move all the constants to the right side, and luckily we only have one constant, so it's going to be x squared minus 6x. And actually, for the sake of space, because this is going to take up space, I'm just going to go ahead and erase this and put that over there. That's okay. So negative 19 over 3. Okay. So that's the first two steps. I made my a value, the value here, 1, by dividing the entire problem by 3. And then I moved all my constants, and in this particular case, it's just 19, or 19 over 3. I moved it to the right side. Okay. So now comes my algorithm. Here's what I do, and I encourage you to do this as well. I have a 0th step, okay, a 0th step, and what I call that is b halves squared. Basically just the formula, right? Okay. Well, step 1, what I'm going to do is I would go ahead and plug that b in. Okay. Step 2, I would go ahead and divide by 2, so I'm leaving it blank, and I'll show you more as we proceed. And step 3, I'll go ahead and do the squaring process. Okay, so I'm going to color coordinate this the best I can. Okay, so in this particular problem, what is b? Well, b is negative 6. Negative 6. It's not negative 6x. Okay, b is just the constant, so negative 6. Okay, continuing on with the color coordination here, we're going to put this in red. Negative 6 divided by 2, well, that is negative 3. See, notice how I just kept the entire parentheses just completely blank because I'm taking that number and dividing it by 2, right? And then lastly, what is negative 3 quantity squared? Well, that is 9. Okay, so the whole point of this is to make the left side a perfect square trinomial. A perfect square trinomial, again, is this right there, the left side of C. Okay. So what I can do now is I can rewrite this equation. I can write it like this. I can write x squared minus 6x, okay, and then plus 9, okay, and that's equal to negative 19 over 3 and plus 9. Okay, now again, the whole point of doing this is to make the left side a perfect square trinomial. All right, we need to make the left side in the form of some a plus b quantity squared. All right, and that's what we did do. Okay, we can now rewrite this as the left side as x minus 3 quantity squared. Okay, but Professor Brown, that's cool and all, but how'd you get that? Well, one of two ways, okay? One of them being, well, I could just look at this, right? And then I could factor it in my head, all right? But some of them aren't that easily factorable, okay? But the best part, and this is why I color coordinate this, is I didn't actually even factor that in my head. All I did was look over here at step 2, and I know that that negative 3 goes here. Okay, which is why I go by that particular algorithm. All right, and for those, I say algorithm a lot. An algorithm is just a series of steps. That's it. Okay, all right. So that's what the left-hand side looks like, and the right-hand side. All right, well, negative 19 thirds plus 9. Okay, and again, this might be something you are tempted to use with a calculator, but I'm telling you, it's just a lot easier if you keep these in fractional form. Okay, negative 19 thirds plus 9 in a calculator, you're probably going to get. I mean, you will definitely get a decimal. You'll get what, like 2 2/3 or something like that. But we keep it in fractional form like this, negative 19 over 3 plus 9. Okay, so we need to get a common denominator. So what's a common denominator? Well, it's 3. So it's going to be plus, and I'll go put that in yellow. All right, 27 over 3 is the same thing as 9, right? Okay, so we can continue here. We got x minus 3 quantity squared is equal to, okay, so now that we got a common denominator of 3, we just basically add 27 of negative 19, so we have 8 thirds. Okay, and then we can proceed here, just like we did on C in example 2. Okay, we square both sides, so by squaring both sides, we've got, and we'll put this in green since we're on home stretch here. We square both sides. Take the square root of both sides. We've got x minus 3, don't need that, is equal to plus or minus the square root of 8 thirds. And then we add 3 to both sides. 3 plus or minus the square root of 8 thirds. And the the 8 can be reduced, and we can rationalize the denominator and so on. And these are things that we've done before, and I just ran out of space. But we will, if you want, we'll just go ahead and snip. We'll snip to that, yeah. So do I have room for that? Not entirely. All right, so we'll just keep it like this. Obviously, it's an incomplete solution, but you know where to find the complete solution. Again, completing it from here is just things that we know about. The main part is getting to the completing the square process and how we get there. Okay, and again, I color coordinated everything so you could see what goes where. I'm pretty sure we have one more example that we can work on. Okay, so same thing. What I'm going to do is I'm going to divide everything. I'm going to go ahead and divide everything by 2 and move, or I'm going to divide everything by 2 as I rewrite it, okay? So by rewriting it, if I divide by 2, this becomes x squared minus, that's a nice crooked 5, or minus 5, huh? Minus, same thing, oh, whatever. Minus 5x minus 3 is equal to 0. And of course, you know, we want to put the 3 on the right side, okay? Because we want to put constants on the right side. So x squared minus 5x is equal to a positive 3. All right, I did step 1 and 2. I made sure my A value is a 1 by dividing everything by 2. And step 2, I put my constant on the right side, in this particular case, the 3. Okay, so now what I'm going to do now is, again, write my algorithm. My 0th step, again, is just basically the b halves squared. That's it. All right, step 1, I leave a blank empty for the b because I'm going to be plugging that in. Step 2, I'm going to leave the whole thing empty because I'm going to be dividing by 2. And step 3, I'm going to leave the whole thing blank because I'm going to square it. Okay. So in this particular problem, let's see what colors did I do. I think I used, okay, red and then yellow. Okay, so what's my value of b? It is -5. Okay, and again, it's not -5x, right? Just the b value, the constant. So it's -5. Right? -5 halves, well, that's just, unfortunately, -5 halves. And what is -5 halves squared? Well, that is 5 squared is 25. 2 squared is 4. Okay, so we're going to do the same thing here. We're going to go x squared minus 5x, and then plus 25 over 4, and that is equal to 3 plus 25 over 4. Okay. Now, realistically, there's nothing wrong with it. I don't even have to write this step. I don't have to, or at least if I did, I would write it instead like this. I would write x, and then again, we're looking at the red, minus 5 halves quantity squared. Okay, and then I could write, is equal to 3 plus 25 over 4. Okay, so if you wanted to skip this entire step here, that's completely fine because we know that this x minus 5 halves quantity squared is the same as this. Okay, but early on, I would, I guess, suggest make sure. Oh, well, I guess I'll have to erase all that, huh? I would make sure to write this step. But again, it is kind of redundant. Once you realize that, excuse me, oh man, I'm so sorry about that. That once you, I'm gonna have to edit that out. What's the time? 32:50. Okay. Negative x minus 5 halves quantity squared is the same as x squared minus 5x plus 25 over 4. And then we just have to combine the right side. Okay, so what's the common denominator of 3 and 4? All right, well, 3 over 1 and 25 over 4. Well, that's just going to be 4, right? So it ends up being 12 thirds. Okay, everybody, I'm sorry. No, 12 fourths. Sorry, I knew something wrong. 12 fourths. So 12 fourths is the same thing as 3, right? 12 divided by 4 is 3, so that's fine. Plus 25 over 4. Okay. All right, well, 12 fourths and 25 fourths, they have a common denominator. That common denominator obviously is 4, so all we have to do is add the numerators. So I can proceed here. X minus 5 halves quantity squared is equal to 37 over 4. We know that if we take the square root of both sides, we got x minus 5 halves is equal to the square root of, and I'm going to go ahead and write it like this first, 37 over 4, right? Well, we know that this is the same thing as saying the square root of 37 over the square root of 4. Okay, well, square root of 37 isn't a perfect square, but the square root of 4 is, so I can just write that as the square root of 37 over 2. And then continue on, we've got x is equal to, we're going to add 5 halves to both sides, so we've got 5 halves plus the square root of 37 over 2, which is equal to my common denominator is a 2, so it just becomes 5 plus the square root of 37 over 2. Okay. All right. And I believe that's the end of completing the square processes. These two examples are really good because, you know, the first one really gets your feet wet. The second one happens to be a b value that is not easily divisible by 4 or does not evenly divide by 2. So those are good. Quadratic formula. Okay, so real quick, let's do this. At this stage in your college life, you and I are not much different. Okay, what I mean by that is my first year, my first year of college, undergrad, obviously, I was going for psychology or behavioral science. Okay, and I took college algebra. And when I took college algebra, I had no interest in mathematics. I'm like, I just want to get in here, get done, and leave. All right, so I didn't pay too much attention to stuff, and I remember my mindset. In fact, one of my mindsets might have been with the completing the square. Might have been something like, all right, so this completing the square nonsense, I'm not used to it. I'm not going to really try too hard. I just hope there's not many of those questions on the test. All right, I was a horrible student. Obviously, things changed later on in life, but I was a pretty bad student early on. And so, before I even knew anything, I would hear this quadratic formula, and of course, you know, the quadratic formula being here, and I guess I'll just show you right now. And you know, you've seen it, you've heard it. There's a song attached to it, which I didn't know about until like 2 years ago. But this quadratic formula, that's not what I want. All right, that quadratic formula. How did somebody come up with that? Was there somebody hundreds of years ago sitting in a dark room just with, you know, a candle going out, just plugging in A's and B's and C's and square roots and squares, and then finally, you know, he's like, oh, this combination works. And not only does this combination work, it works every single time, right? At least that's what I thought, right? And you would think something this prevalent in our college mathematical textbooks would have a name on it, right? I mean, somebody famous should have a name attached to this quadratic formula because it is so complex, right? Well, the thing is, and of course, the more I got along in mathematics, I realized it's actually not that complex at all. Okay, so let's discover. All right, so we know that the definition of quadratic equation is ax quantity squared plus bx plus c is equal to 0, which, by the way, a couple things. I know some of you do take notes. I do know I go really fast sometimes, but for this, you do not have to take notes on this. This is just showing you a discovery. If you want to follow along and write down, you are more than welcome to, but this is nothing about this is going to be on the test, except for the end, I guess, okay? But anyways, let's go on. So we know this is our quadratic. Oh, that's a nice little tail on that x, huh? This is a quadratic equation. And if we were to proceed completing the square, we know that we need to get the value in front of the x squared to be 1. So what do I need to do? I need to divide the entire problem by a. So if I divide the entire problem by a, okay, I get x squared plus b over a x plus c over a is equal to 0. I need to get all the constants on one side, so the only constant here is c over a. So this becomes x squared plus b over a x is equal to negative c over a. Then we're going to do our algorithm over here. B halves quantity squared. I'm going to substitute the b. We're going to divide by 2, and then we're going to square. Okay. All right, what's dividing by b? Okay, the value of b is not just b here, right? In this particular case, it just so happens that my variable is b, but the b value is the number in front of the x. And in this particular case, it is b over a. So b over a divided by 2. What's b over a divided by 2? Well, that is b over 2a. And what is b over 2a quantity squared? Well, that's b squared over 4a squared. Okay, again, I just square the numerator and the denominator. Okay, so I'm going to go ahead and do the whole skipping that step I said earlier for the sake of room here, I think. So my left side can turn into x, and then it's going to be plus b over a, again, from step 2. I'm sorry, b over 2a. b over 2a quantity squared, and that's equal to negative c over a plus b squared over 4a squared. Now again, this plus b squared over 4a squared would be at the end of this, okay? But I went ahead and factored it, and I factored it to this, okay? Because, well, we can do that. All right, so next up, we're going to get a common denominator on that right side. So let's go ahead and rewrite the left side as x plus b over 2a squared is equal to, okay, so I need to get a common denominator. That common denominator would be 4a squared. Okay, so what I need to do, it looks like, is I need to multiply just this fraction by 4a over 4a. Just this fraction. Okay, and I'm allowed to do that again. All right, so let's discover why I'm allowed to do that real quick before I proceed. Okay, so I am 33 years old. Okay, you could say I am 20 plus 13 years old. Everybody agree? Yeah, that's fine, right? That makes complete sense. But what if I said I was 33 is equal to 20? All right, now 20 times was 3 pi x over 3 pi x. I don't need that one. Plus 13. That still makes sense though, right? Because 3 pi x over 3 pi x, so that's just 1. And 20 times 1 is 20, plus 13 is 33. Okay, so I'm allowed to make that manipulation there. All I'm doing is multiplying that one term by 1. I'm not changing its value at all. It's still 1, okay? So that's the manipulation I'm going to make here. So I'm going to rewrite this as minus c over a. And again, I'm going to multiply it by 4a over 4a. And I'm trying to keep the color coordination nice. Okay, so we're going to zoom up here. So this becomes, the left side's still the same, x plus b over 2a is equal to, okay, so what is negative c over a, looking down here, negative c over a times 4a over 4a. Well, that just becomes 4ac in the numerator, so it's going to be a minus 4ac, negative 4ac all over 4a squared, 4a squared, sorry. And it's going to be plus b squared all over 4a squared. Okay. And let's continue on. Okay, so I have a common denominator, so I can just I can write this entire problem over 4a squared. Okay, so it is a negative 4ac plus b squared, right? I just combine my numerator. Well, for the sake of, a not having a negative out front, and b knowing that we're just going to have the b squared out front whenever we conclude this, let's just go ahead and rewrite that as b squared minus 4ac. Okay, and hopefully you see where this is going now. All right, so next I'm going to take the square root of both sides, so it's going to be x plus b over 2a is equal to the square root of b squared minus 4ac all over 4a squared. And like we saw on the previous example, this is the same thing as saying the square root of the numerator over the square root of the denominator, right? Well, the square root of the denominator is a perfect square. The square root of 4a squared is simply 2a. So we can rewrite this as x, and I'm definitely running out of room. 2a is equal to the square root of, and I'm gonna go ahead and write this on the next page. Okay, kind of keep this somewhat pretty. X must be over 2a. So shoot, I can't remember. Okay. Okay, good. Okay, so now I can write this as x plus b over 2a is equal to the square root of b squared minus 4ac all over, and then again, I said the square root of 4a squared is simply 2a. Okay, well, I'm going to isolate the x on the left, so by isolating the x on the left, I'm going to have x is equal to, I'm going to subtract b over 2a from both sides, so minus b over 2a plus, oh, that was an error there, plus or minus, plus or minus. When I took the square root of both sides, I forgot to do the plus or minus there. There we go. Plus or minus the square root of b squared minus 4ac all over 2a. And then we have a common denominator. So by combining my denominators, I've got x is equal to negative b plus or minus the square root of b squared minus 4ac over that combined denominator of 2a. Whew, that's it. Quadratic formula. All right, so we see how we can derive the quadratic formula from the quadratic equation using completing the square. So that's why this quadratic formula doesn't have some famous mathematician's name tied to it, because it is, and I hesitate to say this, you know, in a general sense, but it is easy to derive. Okay, so let's move on. I just want to show you. I think it's cool. Here we go. So in example 5, we see how to solve a quadratic equation by completing the square. In fact, the method of completing the square can be used to solve any quadratic equation. All right, so that's good. So again, the way we solve quadratic equations are, you know, the first step we do it is, you know, factoring, right? The second step we did was the square root, right? You know, it doesn't always work nice, but the third step we see was completing the square, and it always works. That's what we want. We want something that always works. We don't want to tinker around with things that might work, right? So that's good. Completing the square always works. However, this method is often long and tedious. Yup. If we solve the general equation by completing the square, which we did on the previous few pages, we can obtain the quadratic formula, which we did. The quadratic formula can be used to solve any quadratic equation and is often less tedious than the method of completing the square. Ain't that the truth? Okay. Be sure to work through the derivative. Oh, and we did. We derived the quadratic formula. Anyways, this is our quadratic formula. The solution to the equation ax squared plus bx plus c equals 0, where a is not equal to 0, is given by the formula. This 100% has got to be memorized. There's many things that have to be memorized. This is definitely at the top of the list, though. Okay? Donate much more of your brain cells to this formula than the other things I told you to memorize. There. All right, so there's nothing really to the quadratic formula. Matter of fact, a familiar expression to the quadratic formula is plug and chug, because you plug in A, B, and C, and you chug, right? So I'm just gonna go ahead and just snip this whole thing, because again, it's nothing. I'm sorry, I was really burpy today. It's nothing really earth-shattering, right? You plug in the values. So I'll read along with this. I just don't feel like writing it out. The quadratic equation has values a equals 3, right? A equals 3. Boom, that's the 3. Well, I guess I have to move it. There's the 3. B is equal to 2. B is equal to 2. C is equal to negative 2. C is equal to negative 2. Substitute these values in the quadratic formula. Okay? And for the sake of this, I'll go ahead and snip the quadratic formula from the previous page right underneath it so we can just kind of maybe follow along. Right? Negative B, well, so B was 2, so negative 2. We plug it in. And, you know, I'll probably do the next one because I bet we're going to have negative, negative, and that's what becomes a little complicated, but not abundantly so. Just, you know, dotting your T's and, or wait, dotting your I's and crossing your T's. So we just follow along. We plug in B's where the B's are. We plug in A's where the A's are. We plug in C's where the C's are, another A. One mistake I do see many students make is that this particular problem, it is all over 2A. Okay, many students just put the fraction over 2A. Make sure you put the entire problem over 2A. All right, and then just proceed. That's it. It's plug and chug. Can you do arithmetic? You're good to go. The next one might be a little more difficult, and I'll get on that one.